Welcome to Lesson 30. Today we are going to figure out how oxidation numbers are assigned or calculated. In this lesson, we will describe oxidation numbers, how to find them on the periodic table, and do some practice problems to calculate the oxidation numbers in a compound. An oxidation number is a positive or negative number that is assigned to an atom to indicate the degree of oxidation, loss of electrons, or reduction, gain of electrons. Remember that on the periodic table, all elements are neutral or they have no charge. We will also be working with polyatomic ions, which are a group of ions bonded together that have one single charge. The polyatomic ions that we will use in this class are listed on reference table E, so no need to memorize. So when we look at the periodic table, we know that it is the periodic table of neutral elements. So when we talk about an atom has no charge. The charges that we talk about when atoms obtain their oxidation number are only when they are in bonds. Those could be ionic bonds or molecular bonds or covalent bonds. In chemistry, the word oxidation means the loss of electrons. We can remember the definition of oxidation by remembering Leo the lion says grr. The loss of electrons is an oxidation, and the charge goes up. Since one element loses an electron, another element must gain it, as matter cannot be created or destroyed. So the opposite of oxidation is called reduction. Every oxidation must happen simultaneously with a reduction. When electrons are gained, it is called a reduction, and the charge goes down. This number line can give you a good visual of what we mean when we say that oxidation is an increase in oxidation number, while reduction is a decrease in oxidation number. Here we have a neutral sodium atom, which loses one electron to obtain a stable, noble gas valence electron configuration. When a neutral sodium atom with zero charge becomes a sodium cation with a +1 charge, its oxidation number increases from 0 to 1. Now, when a sodium atom loses its electron and undergoes oxidation, it must give its electron to another atom. In this case, the atom is chlorine. When a neutral, zero-charge chlorine atom gains an electron to obtain stable, noble gas valence electron configuration, it will have a decrease in charge. Reduction means the charge goes down. In a bond, sodium has a positive oxidation state, and chlorine has a negative oxidation state. Because their charges are opposite, they will be strongly bonded together as an ionic bond between the metal, sodium, and the nonmetal, chlorine. Here are the 4 rules that you will need to follow in order to assign oxidation numbers to any element, whether it is free or in a compound. Take a minute to pause the video, write down these rules, and we will work through an example for each rule. The first rule for oxidation states is simple. If an element is not in a compound, it's not bonded, and there is no charge listed in the upper right-hand corner, then the free element will have a charge of 0. Here, these are all free elements. Notice that the diatomic element chlorine is also considered to have a charge of 0 because this is in its natural state. The next rule has to do with compounds. The sum of the oxidation states of all the elements in a compound must equal 0. So if we look at the ionic compound aluminum chloride, since aluminum only can have the charge of +3 in a compound, the 3 chlorines must have a charge of -1. This way, the total charge of the positive ions equals the total charge of the negative. Okay, so let's look at carbon dioxide to see if we can make sense of this. Carbon dioxide is made up of 1 carbon atom and 2 oxygen atoms. Next, we look on our periodic table and we see that carbon has several oxidation states, but oxygen can only ever have the oxidation state of -2 in a compound. If oxygen has a charge of -2, giving the oxygen total charge to be -4, carbon must have a charge of +4. Looking on the reference table, this is a possible charge of carbon. The third very important rule is, if they give you the oxidation state of an ion, use that number. So here we have the polyatomic ion sulfate. We are given that its total charge is -2. So 1 sulfur and 4 oxygens must have the charges as listed in order to get to a total charge of -2. Here is one more example of how to calculate the oxidation number of elements in a compound. In this compound, sodium sulfate, we can find the oxidation number of sodium and oxygen on the periodic table, but sulfur has many choices for oxidation number, so we must calculate it. Since we have 2 sodiums, the total charge of sodium is +2. Since we have 4 -2 oxygens, the total charge due to the oxygen is -8. 2 and -8 mean -6. So the sulfur must have a charge that will allow us to cancel out the total charge, or a charge of +6. The sum of the oxidation numbers of all of the elements in a compound is always 0. We will work more together calculating oxidation numbers in class, but this is simple. If you have any questions, make sure that you bring them to class. See you soon.